This lesson is an introduction to partial fraction decompositions. So let me first begin by asking you if we perform the following operation of 3 over x plus 4 plus 2 divided by x minus 3, how do we exactly solve this? So the thing with this is, obviously, as you know, you would take the common denominator here, so you do x plus 4 times x minus 3. And we're just looking at this, so we know that the numerator here, 3, has to be multiplied by x minus 3. And then we have plus 2 times x plus 4. Right? And then we can solve this. We can use we can distribute these coefficient here, or I guess you could just use the distributive property here, and you get 3x minus 9 plus 2x plus 8. And looking at this, we know that this is 5x. You combine the like terms, minus 1 divided by x plus 4 times x minus 3. So this is your answer here, right? But this is not exactly partial fraction decomposition. What this terminology up here means is that you're really taking this this factor here, or this value, and you're trying to split this up into two fractions. So what we're really doing is we have this and we want to split this into two factors, or two fractions. That's why we call this partial fraction decomposition. So when you encounter problems, you will see problems that give you something like this, and then you will be splitting that into multiple fractions, and it may get more complex, as you will see later. So that's the idea. And now I'll just give like a basic problem, and this problem that I give here in this lesson involves distinct linear factors. So if I give something like decompose 3x divided by x squared plus x minus 2, something like that. So looking at this, we can factor the denominator, right? So we can factor this out, and we see that it's x plus 2 times x minus 1. So these are two distinct linear factors, right? Because obviously these two factors are different and they're linear, so they're distinct linear factors. So that's our case number 1. So this is how we factor the denominator. And now really what we're doing is we're trying to break this into fractions. And so the technique that you do it, the way how you do or how you break up fractions or break this into several fractions, is you just take any variable. So let us say a, and you do a divided by x plus 2 plus b divided by x minus 1. And so what we're really trying to do is we have these two fractions, right? And we're adding these two fractions, and we're setting the sum equal to 3x divided by x plus 2 times x minus 1 here. And so this is what we are trying to do exactly. Now, if we have something like this, we can obviously find the common denominator here. Again, we would just do a times x minus 1 plus b times x plus 2, and this is really all over x minus 1 times x plus 2, right? And we have this equal to 3x divided by x plus 2 times x minus 1. So you can see here that the denominators are equal, right? They're the same. And so because they're the same, and you know that this expression is equal to this expression, we can further deduce that this numerator must be equivalent to 3x. And so if we know this, really we can just take this part here, because we know that the numerators must be equal. So we know that this part over here must be equal to 3x. And now we can set different values in for x. So we can say, let x be equal to 1, for instance. And why am I choosing this specific values? Because if we substitute x in, we get 0a. And then we substitute 1 in for x here, we get 1 plus 2, 3, so we get 3b. And then we plug in 1 back, we get 3 here. So in dividing both sides by 3, we get b is equal to 1. So that's your b value here. And similarly, we have to take a value for a, right? So we can so here we can also say let x is equal to -2, because if we do this, clearly the b's go away because we have negative 2 plus 2, that's 0b, and then we have negative 2 minus 1, that's negative 3a, right? So we have negative 3a is equal to negative 2 times that's negative 6. So we have a that is equal to 2. So we know what a is and we know what b is, right? And really our final answer here is just a and b, these values, and we're really putting a back in. So we have 2 divided by x plus 2 plus b was 1, so 1 over x minus 1. So this question here has been decomposed into these two fractions here. And again, you can use the common denominator technique that I showed earlier as the first problem to verify that you do get this. So this is your final answer. And in the other videos that will come along, I'll be going over more problems. So thanks for watching.